Hello learners, welcome back to the education program online. I am teacher Christine Adekul, taking you in mathematics senior 3 and senior 4. So the previous lesson we had, it was on application of differentiation, and we looked at the application on differentiation part A, that is on a stationary point. And then we also went far looking at how to identify the types of stationary points, which we say they are three: minimum, maximum, and a point of inflation. And then we said, how do we identify these categories of stationary points? We said we can identify using two methods. The first one, we said using the first derivative of a function, and then the second one using the second derivative of a function. And we stopped it on part A, that is Roman 1, which is methods of identifying the stationary points. Methods of identifying the stationary points. And we said one of the methods is using the first derivative, that is using the first derivative, and under it we looked at how do we use the first derivative in identifying the maximum. And then B, we are now looking at how to use the first derivative in identifying the minimum stationary points. The minimum point of a function. Minimum point of a function. So we said how to use the first derivative in identifying the minimum point of a function. We also look at the graph, how we did with the maximum points. So when it comes to this, we simply say a minimum point of a function, a minimum point of a function that is f of x at x equals to c, is a point at which f c equals to 0. Fc equals to 0. Then we draw our table. So our table is showing how do we identify the x, and then we have f1, and then we have fx, f of x. So what happens to x? x is less than c, and then we have f of c, and then we have x is less than c. So here we have a gradient less than 0, and then a gradient equals to 0, and then a gradient greater than 0, and then a gradient less than 0. What happened here is it will be increasing and then here will be decreasing. And then here will be stationary, and then here will be decreasing. Here will be decreasing. And then we have a sketch curve. So our sketch curve here will be where we have this part as our stationary or gradient equals to 0, and then shall have here, this is the gradient is greater than 0, and then here the gradient is less than 0. So this is what we call a minimum point or a minimum turn. So my learners, I want you to look at the blackboard. When you look at the first derivative, using the first derivative in identifying whether the point is minimum or the point is a maximum. But for this case now we are looking specifically on minimum point of a function. So the minimum point of a function, when you look at our table here, we said the first column we have x, and then the gradient, and then here we have a function of x. Mostly we look at the gradient and what happened to the function. If the gradient is less than 0, what will happen to the function here? The function will decrease. And then if the gradient is equals to 0, then the function will be at a stationary point. It will be at a stationary point. And then when the gradient is greater than 0, then what happened to the function is it will be increasing. Meaning that when you look at the maximum is opposite of minimum. Remember that in our previous lesson we said here there will be increase, and then here will be a decrease with the case of maximum. But with this minimum, here will be a decrease, and then here will be an increase. So it becomes opposite of the other one. And then when you look at our illustration, the curve, so the curve will appear in a U shape. So a U shape, meaning that on your left hand, what happened? The gradient will be less than 0. And if it is less than 0, what happened to the function? It will be decreasing. And then on this side, on the right hand, you find that the gradient is greater than 0, which means that the function will be increasing. And then here is our stationary point, which is the gradient is equals to 0. So this kind of a curve is what we call a minimum curve, or a minimum point of turn. Then we look at part C. How do we still identify, use the first derivative to identify point C now, which is the point of inflation. Point of inflection. So the point of inflection here of a curve is not going to be like the two here that we looked at, the minimum and a maximum, because what happened here with the minimum and a maximum, there will be increase and decrease. But when it comes to inflection, it will be a constant. It does not change. It can be positive throughout, or it can be negative throughout. That is what happens with the case of inflation of a curve. So we simply say a point of inflation of function x is a point C, which is function C where the gradient of C is equals to 0, and B inflation or inflection of a function is not like maximum. It's not like maximum or minimum. Maximum or minimum. Maximum or minimum where the gradients continues. Where the gradient continues. The gradients continues. Where the gradients continues positively. Where the gradients continues positively. Or negatively. Positively or negatively. In bracket, increasing or decreasing. Increasing or decreasing. Decreasing on the graph. On a graph. I will explain for you, you will understand it, and then next NTNB says turning points varies with the degree of a polynomial x with the degree of polynomial with a degree of a polynomial x. Polynomial of function x. Of function x. So let me explain this part so that you can understand it well. We said if we are looking at identifying the point of inflection of a curve using the first derivative, in this point you find the gradient remains 0. It does not change. It does not increase neither decrease. It remains constant. It is not the case of maximum and minimum, because when you look at maximum and minimum, the gradient keeps on changing. It can be positive, greater or less. So meaning that it keeps on increasing or decreasing. But the case of this, it is constant. That is what it means. And then this part, you find that when you are now entering into calculation, you need to take note of this, that any turning point, which is a maximum, minimum, or in point of inflation, will define that the degree of it is polynomial, which is the x, keeps on varying. You may find the x is raised by 2 or x is raised by any power. That is what it means. So if it varies, that means it may cause, it will determine, because of that varying of the degree or the power of a variable, will result to any of these turning point, either maximum or minimum or a point of inflation. So learners, with this explanation on how to identify the stationary points, I want you to take this and you go and try to research on this question. This is a task for you. You go and try in your free time. You are given a function. You are given a function y equals to f of x, which equals to x squared minus 6x plus 1 determine the coordinates determine the coordinates of the stationary points of the stationary points by completing the table below. So I want you to go and research on this during your free time. You can research as a group or you research as an individual. Search as a group or as an individual. So here they have given us x gradient and then a function of x, and then here is x is less than c, and then we have x equals to c. and then we have x is greater than c. So here we have 0. So go and complete these parts here. Those blacker spaces, you complete them, and then you have number 2, show that function y equals to fx, which equals to x cubed minus 3 x square plus 8 has turning points, at 0, 8 and 2, 4, and determine their type, types. So that is the activity or the task I'm giving to you. Copy it, then you go and try to research on it. You get me the correct answer using what we have just explained, the stationary points. So let us now look at how do we calculate this stationary point. How do we calculate the stationary points? So let us look at example 1. So example 1 says, describe the critical points of the following. Describe the critical points. Describe the critical points of the function y equals to fx equals to x cubed minus 3x square minus 24 x plus 12 So they will ask you like that. Describe means you are to find the stationary point or the critical point of the given function, and then you also go ahead by telling the examiner what type of a stationary point have you got. Is it a maximum or a minimum? So before we go to the solutions, I want you to take these steps, or before we answer this, I want you to take these steps down. Steps to follow. So the steps that you have to follow when you are finding the stationary point. 1, you say differentiate. Step number 1, differentiate the function. Step number 2, divide all terms by common coefficient if possible. By common coefficient if possible. If possible. And then Roman 3, you factorize, and then Roman 4, get the solution of x. Get the solution of x. Get the solution of x. And then substitute the values of x in the function y. Roman 5, substitute the values of x in y to get stationary points. Stationary points. So learners, as long as you follow, you understand these steps, then finding the solution for any stationary point or critical points becomes very easy for you. So let us follow those steps and we see whether we arrive to the correct answer. So for step number 1, our y is given as x cubed minus 3x squared minus 24x plus 12. So our first solution is to differentiate. That means we say f, or that is the gradient or the first derivative, or you may say dy over dx equals to what? So we differentiate this. So when we differentiate, we remember we differentiate a term by term. We say the coefficient here is 1. So we say 3 times 1 will get 3. And then the power will reduce by 1. And then we have x raised to what? Raised to 2. And then minus coefficient is 3 and the power is 2. So we say 2 times negative 3 gives us negative 6. So when you reduce 1 from 2, it gives us 1. So we say it will be 6x. And then here we have the power of x is 1 times the coefficient, which is negative 24. It will give us negative 24. And the power will remain 1 minus 1, 0. So any number power 0 gives us 1. So when we differentiate 24x alone, it will give us 24. And then this will be 0. So this will be our first differentiative or whatever, or our first derivative. Then now, step number 2, we said you divide if possible. So when you look at this outcome here, you find that the coefficient 3 can go with all these figures, the coefficients of x and the constant here. So that means you divide. It is not a must that you are supposed to divide. If it is possible, since this one it can be possible, then we can now come down and say divide by saying we have 3x squared divided by 3 minus 6 divided by 3 minus 24 divided by 3. So we arrive to what x3 goes with 3 and remain with the x squared. And then here we have by 3 we remain with the 2x, and then by 3 we remain with the negative 8. So we remain with the negative 8. So in this part, this is where you can now factorize, because it has given you a quadratic equation. So when we factorize this, we simply use what we call error and trial method, or three-factor. So we break the first term and we break the third term. So the third term, we look at the factors. Which factors can we multiply to give us 8? We have negative 4 and then positive 2. So this, we shall now have this x with the negative 4. With the negative 4. And then we have, or we shall have x and positive what? Positive 2. So with these are now the factors. Then we come now to part Roman 4. Get the solution. So for us to get the solution, we have to quit all of it to 0. So when we quit this to 0, it means negative minus 4 equals to 0. X will give us positive 4. So here x is positive 4. Or if we say x plus 2 equals to 0. So when this 2 comes to the other side, we remain with the x equals to negative 2. So these are the solution of x, solution set of x. Then now we come to Roman 5, which is substitution. Since we have known now if x is this and y x is this, what will happen to the given y? Then we substitute.